Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering geometry, quarter 2, quiz number 1. Let's dive right in. Our first question says, if triangle CDE is congruent to triangle STR, which is true? So because C and S are both in the same position, angle C is congruent to angle S. Because D and T are both in the same position, angle D is congruent to angle T. Because E and R are in the same position, the third part, then angle E is congruent to angle R. Because CD and ST are both in the first and second positions, side CD is congruent to side ST. Because DE and TR are both in the second and third positions, that means that side DE is congruent to side TR. And lastly, because C and E are in positions 1 and 3, and S and R are in positions 1 and 3, that means that side CE is congruent to side SR. So there's another question a little further down in your quiz, and it says that given those two triangles, CE equals 4x plus 3, and RS equals 7x minus 9. So remember that CE and SR or RS are equal to each other. So you can set these two equal to each other and solve for x. So when you do the algebra, you get that x equals 4. But they don't ask you on the problem what x equals. They want to know what CE equals and RS equals. So we're going to take our x equals 4 and we're going to plug it in back here for x. So you can plug it in for either one, and what you'll get is that the side is 19, and since they're both the same, they're both 19. All right, in the next question here, they're talking about a paper airplane, but the fact that it's a paper airplane is irrelevant. What it really says is that you have a quadrilateral, QRST, that is congruent to a different quadrilateral, HIJK. They tell you that the measure of angle I and the measure of angle IJK is 80 degrees. The measure of angle IHK is 152 degrees. And they're asking you for the measure of angle STQ. So we can start by creating our quadrilaterals. So the quadrilaterals can really look like anything because we're going to use the value instead of the way it looks. So remember that these quadrilaterals are congruent. So over here on the right-hand quadrilateral, we have 3 angles that we know and 1 angle that we don't. And the angle that we're looking for here is this green angle, angle STQ, which is the same as this angle over here, JKH. So if we remember that there's 360 degrees inside every quadrilateral, we can subtract out the rest of the values and get our total. And what you find out is that angle K here is 48 degrees. And if angle K is 48 degrees, so is angle T, and that's the answer to your problem. Our next question asks us, what other information do we need in order to prove that the triangles are congruent using side angle side? So they've only given us one side at this point, but we can always use reflexive property to say that XW is congruent to itself in both of these triangles. So that gives us 2 sides, and now we need the angle that's included between the 2 sides. So on the right-hand side, we have this side and this side. And on the left-hand side, we have this side and this side. And the angle between them is here and here. And so those are the angles that we need to know about. So if they give us that information, like this statement, or if they told us that these were perpendicular, if they tell us that ZY is perpendicular to XW, either way, we'd have enough information for those angles that we could prove these triangles congruent by side angle side. Our next question is a 2-column proof, and it tells us that OM bisects angles KMP and POK, and they want us to prove that the triangles are congruent. We always begin with the information that's given to us, and then because OM bisects the angle, we can say that KMO is congruent to OMP, and we can also say that KOM is congruent to POM. So one in the blue and one in the green. This is because of the definition of an angle bisector. We can also say that OM is reflexive to OM, and we end up with triangle KMO being congruent to triangle PMO because of Angle, side, angle. Because here we have the angle and the side included by the other angle. And we have it on both sides. Our next problem here wants us to determine how the triangles are congruent. They've given us that angle A is congruent to angle D, so we'll put our arc marks here, and that AC is congruent to DC, just like that. So we have one angle and one side, and I can also say that this angle here in yellow is congruent to this angle here in yellow because they're vertical angles. So what we actually have is an angle, two angles and a side, and the side is included between the two angles. So we have angle, side, angle again. And our congruency statement would be that triangle ABC is congruent to triangle DEC because of angle, side, angle. Our next problem wants to know how a triangle can be congruent by ASA. So remember what that means. Doesn't matter which angles you choose, you have to have two angles. So we'll pick this one and this one. And in order for it to be angle, side, angle, you need the side in between the two angles. It has to be inclusive. And you just need the other triangle to be the same as the first triangle. So two angles with a side inclusive between those same two angles. And that's your answer. All right, this next one says, given that angle G is congruent to angle M and that GH is congruent to HM, they want us to prove that FH is congruent to HJ. So if we say that G is congruent to M, and if we say that GH is congruent to HM, those are our givens. Our next step would likely be that this angle here, GHF, is congruent to this angle here, MHJ, because they're vertical angles. So next we can prove that the triangles are congruent because here we have angle, side, angle, angle, side, angle. And once we've proven that the triangles are congruent, we can prove that any of the corresponding parts are congruent because of CP/CTC. And that's how you solve this one. Our next one gives us that angle RQS and TQS is congruent, and side QR and side QT are congruent. And they want to know how we can prove that angle R is congruent to angle T. So to begin with, what we want to do is we want to figure out what other information we need. We have one side and we have one angle. And the only other thing we can do here is say that this side is congruent to itself through the reflexive property. So for the top triangle, we have a side, an angle, and a side. And for the bottom triangle, we have a side, an angle, and a side. So we can prove the triangles congruent by side, angle, side. And once we have the triangles congruent, we can prove any of the parts are congruent as well through CP/CTC. And that is how you prove that angle R is congruent to angle T. And for our last one, they give us that LM is congruent to MN, so here and here. And they give us that OL is congruent to ON, here and here. And they want us to prove that the triangles are congruent. So they've given us two sides here, and the only other thing I see is that OM is congruent to itself because of the reflexive property. Then we can prove the triangles are congruent because we have all three sides of both the left and right triangle. So you can prove these are congruent by side, side, side. And that's all, you guys. Good luck. I hope you guys do great. Have a great day.